Evan, are you ready to see your results?
I am, man. I'm nervous.
Man,
I'm
this is fun.
excited.
I'm nervous too. I'm nervous too.
Yeah, let's do this.
All right.
Let's.
A few moments later.
This is actually a very important result. Interesting. My recommendation is definitely immediately get a blood test. This is definitely going to change the way that you live your entire life, probably. Wow, we're going right into it, Evan. This is not planned. I did not
No,
know
not
this.
at
I literally
all.
did not know this.
You are going to have to make decisions about what kind of gene editing services you offer, right? Because it's going to be possible. There's going to be options. It's going to be uncomfortable for people what's possible. It's uncomfortable for people what's possible now. Is there any part of it that you're scared of? You're embedded in this system. You know the capabilities maybe better than anyone. Do you have anything in your mind that you're like, that's just, I'm scared of that. I don't want to bring the company that direction.
Well, to be clear, obviously I'm very scared. I mean,
Kian Sadeghi, why on earth should someone get a genetics test?
hey Evan, thanks for having me. Excited about it today. I think this is going to be a very unique podcast. I think you're unique as a podcast host because it's kind of a great idea to go over your own results live. Why should I get a genetic test? I think there's several reasons. Okay, one reason, which is I think top of mind recently for everyone at Nucleus and for really culture, is family planning. Right, people have hidden genetic risks they can pass down to the future children. Right, like I'm actually a carrier for cystic fibrosis. We'll see if you're a carrier for anything today.
It's very
And
common in Ireland, actually. Ireland has the
Yeah, it is.
highest density of cystic fibrosis genes. I remember learning that. 1 in 19, I believe. It's something for
that's very
people in
true.
Ireland specifically to be very cautious about.
Yeah, 1 in 19, which is very high. And then I think the United States is about 1 in 25. So it's very high. It's very common, which obviously concerned me because I was like, well, is my any theoretical future significant other, like, is she going to be a cystic fibrosis carrier? So, the old joke is, oh, are you
Right.
where do you go to school? What do you do? I'm asking the girl, and then I say, oh, have you done Nucleus? That's sort of my line of question. But yeah, so the first is family planning. So we're going to see that today, and that's going to be really interesting. And that's obviously important to having a healthy child. You want to inadvertently pass down a genetic condition to your kid. Another one is hereditary disease risk. So a great example of this is like Angelina Jolie. She had a BRCA variant. This BRCA variant is a specific gene. BRCA is a gene. Increased her risk of breast cancer by from probably 15% to about 60, 70%. In other words, it dramatically increased her risk for breast cancer. And so what did she do? She got a double mastectomy to reduce her risk to basically negligible for breast cancer. And so there's certain things you can do once you have a genetic marker to take specific action. And then we can talk about that, and that breaks down to a variety of different steps, right? Some things are very clinical, like, oh, take this drug or do this thing. Some things are a little more lifestyle, and we can talk about the kind of range there. Another application is what's called pharmacogenomics, which is how your DNA affects metabolism of different drugs. So if you want to know not just, okay, what am I at risk of passing down to my children? You want to know, what am I actually at risk for? So how do I live like a longer and healthier life given my genetic dispositions? But also you want to know what drugs work best for you. That also you can do from a whole genome test. That last one is not on the platform yet. We're going to actually be adding that in. It's included with your subscription. So you're going to get that, which is going to be pretty cool to see.
Really cool.
And then of course, there's also like fun stuff like traits, for example, like IQ analysis. So I would say it's like disease analyses, there's like trait analyses, there's family planning, there's how your DNA affects metabolism of drugs called PGX. And of course, there's baby simulation too, but that's not live yet. So I'm going to keep that secret, but we'll be pushing that out as well. So you can see if you have a girlfriend or partner, you can simulate your babies.
Super cool, man. Why do you think 23andMe failed? So I said before we hopped on, I did 23andMe like eight or 9 years ago now. Got a very sort of limited genetic report, learned one or two things. Why do you think they failed, and why do you think you're going to succeed?
So I think, whenever you ask why a company failed, it's usually like, there's a weird thing about life where there's a really complex reason and there's, 10 whatever random variables that all interact in some specific way that cause something to fail or something to happen. But also there's just like a really simple explanation. And so I can give you both. I think the really simple explanation is they thought they were a drug discovery company, but fundamentally the data they used could not be used for drug discovery. So obviously if you think that the data you're collecting has value to make drugs and it turns out it doesn't, the core value proposition of your company collapses. Sometimes people will say, oh, 23andMe, like, they didn't build a recurring product. Has nothing to do with DNA, why they didn't build a recurring product. That because the consumer wasn't the customer. you were basically a data feed that they would use to actually make drugs. So this is kind of surprising to people in some sense, in some sense it is, some sense it isn't. Like the first investor of 23 was Google, right? Google was the first investor. And so, Google, Facebook, Web 2.0 more broadly, what was their strategy? What is their strategy? It is the consumer, right, provides data, and then they use that data to subsidize third party, basically. In other words, the customer isn't the consumer, the customer is someone else. Think about it. Google was first investor in 23andMe, obviously, and was married to the founder of Google, and the CEO of 23andMe. And suddenly you find her adopting the same strategy, right? Which is, hey, why would I build a recurrent, consumer application? Why don't I just gather the data and then sell to, GSK? And so they did that. And so they didn't build a recurring platform, not because genetics is inherently non-recurring. Again, you look at the rise of companies like Function, for example, you could have built a recurring health platform and had DNA at the foundation. It would have been very successful. But that wasn't principally their strategy. And so they basically chose the wrong strategy and the wrong technology. Because on that point, it's really important to say, if you think about the decrease in cost of sequencing the genome, which is highly relevant here. So think of your DNA as like a 1,000-page book. Okay. It used to be, when 23andMe launched in 2006, it was $10 million to read all 1,000 pages. $10 million to read all 1,000 pages. Okay, that's crazy. But in 2020, it was about a couple $100. So there's two things that happen in parallel. One, 23andMe's decades-long strategy of collecting a lot of data inside the drug companies, they realize that because the data they collect is fundamentally very limited and it's full of holes, right? What actually ends up happening is that basically you can't identify any novel genetic markers for drug discovery. So that strategy then failed. And then parallel, you have basically this classic innovator's dilemma problem where this decrease in cost is happening. And the fundamental technology 23andMe uses is actually quite old, right? It's kind of going from like search to an LLM, email like that, right? Just doesn't really make sense anymore. And so now I think of the Nucleus, we have a very different strategy. You can see that we're actually building the genetic stack. I think of ourselves as the genetic optimization company. Everything from sequencing, analyzing, and eventually editing DNA for both, by the way, adults and embryos, right? So as you can see, we do everything. We do full stack from preconception screening all the way to embryonic selection, which I don't think that's the top topic of this podcast specifically.
We'll get to it, man. I want to get to it. Trust me.
I'm sure everyone is top of mind for them as they think about their future children, right? So that's a unique thing about us, which is we're very much about serving the consumer in kind of a full stack integrated way. And then the second point is, so in other words, our strategy is different. Right? We don't gather data to sell a drug company, right? We're HIPAA compliant, CLIA certified, capital credit entity. It's just not what we do. And then the other point of this is we obviously are backed by one of the greatest decreasing costs ever, which is the decrease cost of whole genome sequencing. So now you have a strategical difference, you have a technical difference, and of course, you have the raw passion and dedication and killerness of the Nucleus team, Evan. So all this together is, I think, poised for quite a bit of success.
You're well media trained, man. Great answer. And even though we are going to broadcast my genetic results now, which I haven't seen, that is not standard practice for your company. As you say, you don't sell data. Let's get into my results. I'm super excited about this. So I genuinely have not seen, I don't even know the way that you display the information. I don't know how you categorize it. I don't know how you bucket it. I don't know anything about this. The email dropped in my inbox.
Originally? I'm curious. How did you hear about us originally?
I think it was X. I follow a lot of biotech stuff, so I think it was X.
Oh, cool.
It would be in my sphere of sort of science and technology. But the email dropped on my inbox like a week ago, and it was like a 5-year-old being told that Santa arrived on Christmas with all the presents, and I wasn't able to open it. All the presents were there, but I couldn't figure out which. So let's dive in, man. This is completely live. I'm learning my results for the first time. How do you want to display this?
All right, and Evan, I just want to confirm you give me complete authority 100%. And access to your results. Okay, great. So I'm going to share your results. Okay, this is kind of weird to share someone's results, but
have you ever done this before with anyone? No,
live, definitely not. Like I've done it, and people come to me and say, "Hey, can you explain how this works?" And this works, and I explain it all the time. But like live on like a podcast, no. Which is kind of fun. Let's see what we got. All right, let me share my screen.
It kind of feels like you're about to reveal my credit card details. But it's like that personal, but I don't know. Yeah,
I mean, listen, we'll see. Let's see what they say. Okay, interesting. You see my screen?
Yes, your Nucleus results are ready. Oh, I'm so nervous.
Okay, let's see. Let's walk through this. All right, Nucleus results are ready. Ready, Evan?
Yes, I'm ready. I'm nervous.
So these are like our kind of Spotify and Wrapped, right? We want to make results as like accessible as possible for consumers. Let's define risk. As you guys know, all of life involves risk. Right? If you cross the street, there's risk. And when it comes to living a long and healthy life, there's always risk for different diseases. You can't ever entirely avoid risk. Okay. The good news is that you can be proactive about reducing your health risk. And by knowing what your risks are, you can take the first step toward prevention. All right, we basically do a bunch of different things, where we combine genetic results and also genetic information, as well as other health and clinical factors to build models that predict risk. So that's how we do that. And then, Evan, are you ready to see your results?
I am, man. I'm nervous.
Man,
I'm
this
excited.
is fun. I'm nervous too. I'm nervous
Yeah.
too.
Let's do this. Let's see. I'm super excited.
Okay, we tested about 955 conditions. Your higher genetic risk for 3, lower genetic risk for 1. Okay, interesting. Gonna be average for a bunch. Oh, interesting. Hemochromatosis.
You've one high risk
Do you
for
have any
hemochromatosis.
do you have any iron? Have you taken a blood test recently for iron? Do you have any iron
I
deficiency?
haven't. I actually
You should.
haven't. It's interesting that you say this, because talking to my dad, I know he always goes to give bloods, and he always makes a comment about how they say his iron content is off the charts, like it's really high, not in a dangerous way, but he always has
Yes.
made comments about his iron being good.
Well, that checks out completely, actually, based off this result. This is actually a very important result. Interesting. Um, we can go over this. So basically, yeah, hemochromatosis, iron overload. If you have these genetic markers, again, people have different degrees of iron overload. So sometimes it can be like really high and can be life-threatening. Sometimes it can just be elevated. So my strongest recommendation would be, and again, I'm not a physician, disclaimers aside, but given that you have hemochromatosis, or you have the genetic markers for hemochromatosis, my recommendation is definitely immediately get a blood test and look at your
Okay.
iron levels. I mean, if you're indicating that your dad is having high iron levels, then your dad may have hemochromatosis as well. And this is definitely going to change the way that you live your entire life, probably. Wow, we're going right into it, Evan. This is not planned. I did not know
not
this.
at
I
all.
literally did not know this.
So this is basically that I lack an enzyme, or part of the process that would help my body break down and remove of wasteful iron, so that I just have a buildup in my system.
Correct. Yes, you have hemochromatosis is a condition where basically makes it harder to metabolize iron, which is why it results in overload of iron.
Yeah.
And
Very
so I would say that this result is, so having like a rare genetic marker, like 1, you can expect that, but having 2, which is what this looks like, is like more rare. So it's like having variants in your DNA is common. So like you have many differences. However, it's rare for genetic variants to significantly increase your risk on their own as they do for you. Wow, this is a really good Spotify unwrap thing. This is great. Yeah, this is exactly correct. Knowing your risk the first step to prevention. So Evan, don't worry. We have a result here. This is an interesting result. You can be maybe a little bit stressed, a little bit worried. Know that hemochromatosis is entirely preventable, and that actually by knowing this information, you're going to live a much healthier life. You are low risk for 1 disease, colorectal cancer. That's fun. Okay, let's go to
is that
next
result
steps.
related to the hemochromatosis? Is that related to the same gene variant?
No. This is not related.
Separate
this
result.
is just another. Yeah, this is another result.
Okay.
You have you can see your average risk goes down by a bit. Let's go to the platform and let's go right to hemochromatosis. Okay.
Yeah. Did it say what
wow.
my actual risk increase was? I guess we can go into
For
that now.
hemochromatosis?
Yeah, very high genetic risk. It's a red mark.
It is. Yeah. This is a substantial genetic risk. It doesn't necessarily mean that you have this condition. However, it does definitely mean you almost certainly will have excessive iron levels. So this is actually, I would say to the audience, this is actually a relatively rare result. I would estimate maybe around 5% of our customers have a very high genetic risk for something. Definitely the next step is 2 things, Evan. The first step is to talk with the genetic counselor and even your physician. This is a serious result, and this should be communicated to your family, your siblings, and obviously you should consider not just impacting yourself, but also on your future children, which we can talk about. Okay.
Super
So
interesting.
you can see here. You actually did you know this, by the way? You didn't know this, right? That
No.
you were. Wow.
What are the consequences of having iron overload? Is it at a certain threshold that it starts to inhibit other biological function? Will it always sort of inhibit some in function?
Yeah, it could cause brain fog. It could cause we actually had another patient that had hemochromatosis, and he had a probably more severe version of it than you did, but he was feeling very kind of like slow, sluggish. He couldn't really sleep at night, and then we actually identified the genetic marker in it, and it saved his life. Wow, this is
Interesting.
crazy. So okay, this changes the way I'm going to do these presentation. Like, let me just say this, which is like this is by far your most important result. Okay, that's important to understand. Like, this is the result for you. Like, if you ask what I learned from Nucleus, it's that you have these genetic markers. You did say that your father does say have high iron levels. Is that correct?
He's always made a comment about that. Yeah.
Hmm, very interesting. Have you taken a blood test recently?
Can't remember honestly the last time I did an actual general panel blood test. To be honest, it's been a very long time.
Yeah. Well, this is a great trigger for that. I think the next step for you would be to talk to your physician about this result and definitely book a blood test. And what we could do Evan next time is you could actually pull up your blood test results and see if you actually have high iron levels. Again, depending on a condition like hemochromatosis, this puts you at a predisposition to a very high predisposition to. Doesn't necessarily mean you have the disease. Um, it is relatively speaking common for a rare disease, but again, you would expect you have high iron levels. It sounds like your dad does. I think a blood testing is really important for you, and watching your iron levels is going to be critical. We should also talk about the implications on your future kids. So it seems like you have obviously you're homozygous here, which basically means you have two genetic markers. That can be actually a compound het, which is pretty interesting. Basically, you have two bad genetic markers. So if I come here, wow, smooth. You can see that your kids are actually could be at high risk. Um, so basically, you should effectively.
This is so
So
cool, by the way.
basically,
Again, I'm literally seeing all this for the first time, and I really like, as a communicator, how you've laid out this information. Just as a science
thank you so
communicator,
much.
I like how you've laid out all this. This is super interesting.
Thank you so much. Yeah, we take great kind of pride in how we do this.
Great news. If you are thinking of getting your own genetics test done, then Nucleus Genomics, the leading consumer company for genetic testing, is giving my audience 10% off their first test with the code EVAN10. The whole process is super smooth and simple, and you'll get a really intuitive breakdown of everything that you need to be aware of within your DNA. Your breakdown will include risk scores for different conditions that you might be predisposed to. Oftentimes with this information, you'll be able to take proactive steps for your health. For example, in my test, I found that I have two rare mutations that predispose me to a condition called hemochromatosis. This is a condition where my body can't really break down iron very well, and hence it starts to accumulate, which can cause a bunch of negative side effects like inflammation and brain fog. It means that I should get my blood tests done every single year, and I need to be specially aware of my iron levels. But even more importantly, this information is also relevant for my dad, who's always commented about having high iron levels. So your genetics test is of course not just for you, but also for your family, who might discover something important and actionable as well. Get your genetics test done today for 10% off using my link in the description. I really could not recommend Nucleus Genomics more.
So let's walk through this. Okay. So your kids could be at high risk for hemochromatosis. If your partner is a carrier, i.e., they have one copy of hemochromatosis, right? Which, to be clear, I'm assuming your partner does not have two copies. If they have two copies, then you'd expect every one of your kids to have it. But if you have just one copy, you could expect there's a 25% chance that the kids will have the discondition, right? Where they get a bad copy from each of you. There's about a 50% chance they'll be a carrier, which means you don't expect them to have the condition, but you have a genetic marker. And then about 1/4 to 25% will not be um, impacted. And so let me just come here and say, okay. So if I come down, let me just look at this results. Okay. Yeah. So you should really add your partner to the platform. And by adding your partner, you can actually see the combined risk. You can copy your link and share that.
Yeah, I'd love to do that. That would make a second podcast. That'd be really fun.
Yeah, that would be fun. And then you have a physician report here.
Share with your doctor. Interesting. Cool.
And so you can see that you're positive for hemochromatosis.
Very cool. Will we go to the next result unless there's something else here that you wanted to go over?
I think let's go to some of the other results. Oh, so you're a carrier for a couple other things. Okay, this is gonna be interesting. All right, let's go back. Okay, you're a carrier for three conditions. Do you want to do family stuff or health stuff first?
Whichever you think, whatever you would do the
All right, let's talk about some of these.
yeah.
Osteoarthritis, OCD, asthma. Interesting.
OCD,
Okay.
interesting. How what kind of genes impact like something as behaviorally complicated as OCD?
Well, let's take a look. So basically the way this works is that this is based off a specific study. So I mean, you can see the specific study here. It's basically the study that builds polygenic models to basically predict. Can you guys see my screen?
Yeah.
Um,
And not the references if the references popped up.
oh wait, let me share this tab just briefly. This is an example
Yeah.
of like the study we used to like build the model. So when you come back here, so you can always see the references. You can see the different methods and results here if you're interested, and then the scientific details. So basically, you're above average risk for OCD, and then these are the different SNPs that we use. So sometimes people will say, "Oh, you know, I have this SNP, so I have this condition." Each SNP stands for single nucleotide polymorphism. They have very little effect. Okay, and so basically, you would expect that just one of these markers doesn't really tell you much, but if you combine all these markers together, it can give you a meaningful result.
Right.
And so you can see the different genes that the SNPs are associated with. They don't necessarily need to be in a gene though, but that's how that works. So
Very
let me
interesting.
go back up.
I don't think I would display many behavioral phenotypes of OCD. Do you have here somewhere what are the main observable
There's about a
characteristics?
5% chance for you, so it's still pretty low. So even if you're above average, that's why showing the overall risk is so important. Because like you can be above average genetic risk, but it's a disposition, right? So you're above average, you don't necessarily have the thing, which most people with your genetics won't, because obviously 5% is small, but it is an increased chance relative to the 2%. You can see your genetic score here, and then you can see the genetic variants that we analyzed. You can also see on the distribution the range of possible outcomes. Then you can see your risk compared to a typical person. And then I want to show you. Let me show you.
I think it might be important to mention here as well. You know, something I learned from Dr. Robert Plomin, who I know you've spoken
Oh
to, is
yeah,
that
you spoke
like
to Plomin, yeah.
yeah, I big fan. But you know, something he taught me is that OCD sounds like its own distinct thing, but it's really an arbitrary cutoff point, right? It's a quantitative rather than qualitative distinction. So me having a 5.3% more likelihood of having OCD means that I have more OCD labeled type traits, right? But I don't hit, or I don't have OCD is a diagnostic label based on a threshold, really.
Yeah. That's true for any disease too, right? There's always has to be some clinical characterization, which is why things can get really confusing, because it's like, how do you define a disease? Usually the way of thinking about how to define disease is through some like basically threshold model. So you say, okay, like what is cancer, for example? Like it's not like, you know, you wake up one day, it's not a step function. It's not like you wake up one day with cancer. It's like a culmination of many different variables that like develop over time. So part of the thinking of what's called the liability threshold model for disease is basically if you have enough bad genetics and bad environment, you basically go over a threshold that then gives you the condition, right?
Yes.
So like if you're like breast cancer or something, if you're like, okay, well, do I have breast cancer? Really, when you're diagnosed with breast cancer, again, it's a discrete comment like, oh, you have breast cancer. But even though the underlying risk is actually continuous. Does that make sense?
Yeah.
And so, yeah, that's how to think about it. So it's like at some point you have to make a clinical characterization, say, okay, this person has schizophrenia, right? And then this other person is just a little bit crazy. I'm making a joke, but I make the joke about schizophrenia because a lot of founders have high genetic risk of schizophrenia. So like none of them have schizophrenia, obviously, because it's still really low chance, right? It's like probably 1%. But it's interesting to see because it's like and Pullman talks about this all the time. There's like a spectrum of diseases and traits, right? Like people think of disease and traits discrete, but they're actually a spectrum.
Yes. Yeah. Just an important, I think, point to make for this because it gives context to all of the different illnesses that we'll go through. I'm now thinking about my behavior and what's OCD like about it. I can't really think of any, but I'm curious to ask people now what traits are OCD like. So this is asthma.
Yeah.
I actually do have
This is asthma.
like I'm diagnosed asthma, but I never really. Yeah, but I never really believed the results because I've never really had any issues with it. I think when I was 10, I had an inhaler for like 6 months and I played high level sport my whole life, never had any breathing issues or fitness issues. And so I kind of always been a little bit suspect of this, but I technically am diagnosed as asthma, mild asthma.
Wow, look at that. Checks out, doesn't it? Pretty cool. Well, I mean, this is a good example of that, right? Like you have 11% chance, right? But your set of genetic and environment have basically pushed you over the line, so you have asthma, right? So it checks out, right? Because like someone else with lower genetic disposition, but the same environment, environmental factors, whatever, may not have asthma. And so this is why you should really think about these things as dispositions, right? Because you in this case, you have asthma, and it's because in part, because it's always in part that your genetics puts you at a higher risk. Pretty cool.
Yeah. Extremely mild though. Again, it kind of there's people with asthma where I would just consider it a different thing. It's so different in severity. I've never had an asthma attack in my life or any issues, but yeah.
And you're at 11%, so it's not crazy. It's not a crazy increase. Here you can see your negatives. This is actually really important to mention. A lot of people don't understand this. The first thing we do actually at Nucleus is we look for really, really bad markers in your DNA. So we saw the hemochromatosis example, right? Where it's like, hey, there's a given condition. For this given condition, we basically say that, you are like for any given gene we analyze. So in this case, it's asthma. Let me actually scroll down to show this. You do psychoms. So like, for example, there's like 2 genes we look at. So there's hereditary versions of the conditions. So in this case, like Serpina1. Gene names are always so freaking fun. TNFSRF13B. Like,
yeah. I was writing them all out in the list. I was like, God,
really? So the first thing we do is you look for really bad markers in your DNA. These are things that can dramatically increase your risk for the condition. I was talking about BRCA earlier, right? This is an example of like a gene similar to that, but for asthma. And you can see that you're negative. And then if you are negative for one of these really bad markers, then we run the polygenic model. So then this model, what it does is it combines up to 1 million markers into these scores. And then, as I said earlier, the higher the score, the higher chance. So you can see people in your group have about a 13% chance, people in the middle of a 6% chance, people that this ended up coming about a 1.9% chance. And so that's the kind of spread of outcomes you'd expect. And then one of the cool things about Nucleus is we integrate in a lot of non-genetic pieces of information, right? Many of these conditions aren't just genetic, they're non-genetic. So you can see me, for example, with 11.7%. Then you can see you with 11.7%. Then you can see the different variables here, right? And you can see that it's based off of sex and age and genetics. And so that's actually really interesting. I'm going to do a bit of a detour here. I'm going to go to, you can see some of your other risks. We can go to Alzheimer's. That's nice that you're average. Hypertension, average. Oh, nice. Heart disease. So heart disease, you're very low. That's great. So heart disease, for example, what we do is we actually look at cholesterol, blood pressure, diabetes, smoking status, sex of birth, and your whole genome. So that's one of the really, really underappreciated parts of our platform is that we're actually integrating all these pieces of data, Evan, that you provided us, combined with your whole genome to then calculate your overall risk.
Did that say my first name? Is my first name as a feature that is somehow impacting my coronary heart disease?
Your first name?
It says my first name there. Your first name after your whole genome.
Oh. This is just saying that we use your first name in the report. We like to be very transparent and saying like, hey, if you come all the way up and we say Evan. So we're saying, hey, we use this piece of information to write your report, which, obviously it's obvious, but it's very important to me that it's very clear and transparent to consumers what information we use that they gave us. That's very important. Evan, you're the first person ever to bring up that detail. I really appreciate it. That's like an Easter egg. Like no one ever brings that up to me. So thank you.
Well, because I remember reading a while ago, and I don't know if this replicated, that if your name begins with D, you're like more likely to be a doctor. You're like more likely to have a job that begins with the first letter. So I was like really curious, is there an association between your name and you're involving that as a feature? I'm like, that's incredible.
Yeah, we just use it. We just say, hey, we use this. And obviously ancestry as well. We adjust the genetic models depending on the ancestry.
So low risk of heart disease is obviously a very good one. That's good for the family.
You're slightly low risk, and it doesn't seem like you have any other major risk factors. So you can see here that we look at, your sex as well as other factors as mentioned, like blood pressure and cholesterol, and your DNA. So we combine everything. So that's why one of the really cool things about the app.
Yeah, it's super well laid out. I love the interface. I'm excited to play in this later because, again, I'm seeing this for the first time. So all of this is completely new.
I also want to give a disclaimer here, which is I haven't seen these results for the first time. So I'm interpreting the results as I'm going. So if I actually mistake something, I'll let you know right after, Evan. Because like there's a couple of things like I can think about that I'm like, oh, that was like slightly, like not strictly speaking correct, but I think for a general audience it's probably fine because we can go into it. But okay.
Osteoarthritis.
Osteoarthritis. I don't know if you have anyone in your family with this. What's your risk? Still pretty low. Interesting. You should probably watch out for different like exercise with your bones. I'm gonna click AI health tips here. So this is health advice to you, genetic insights into action. You guys see this right on the screen, right, Evan?
Yes. Yeah.
Yeah, so you can actually try it out. It's gonna get better and better. We use generalized information about your genetic health results. You don't share any personal data that can link your identity. Okay. You can see here it's now the AI is taking in. So let's see what it recommends. Lifestyle. Okay, sure. Omega-3 fatty acids, salmon and mackerel can help reduce inflammation. Fruits and vegetables, antioxidants. Kind of generic advice. This is actually really interesting, Evan, if you see this. It says, Evan, given your normal blood pressure and absence of family history for osteoarthritis, here are some health tips. See how it's all categorized? It's all actually adjusted to you. I think that's pretty awesome. That's really cool. I'm glad that we built that level of detail in where we actually consider everything. So we're saying, hey, you have no family history, your typical genetics or whatever, or maybe slightly elevated, and you have normal blood pressure. Here are the recommendations, which are general lifestyle recommendations. We're trying to make the AI better and better because there's like a world where it gets better and better. And again, you can obviously see the different information here, methods, limitations, and different science, and etc. Let's keep going. I want to go to Alzheimer's.
Yeah, for sure.
So Alzheimer's, you're around average, but slightly elevated. Everything from -1 to 1 we consider average. Let's come down here. So let me just pull something up. Okay, so one thing to know is that we one thing about the Nucleus platform is that because you're really young, your Alzheimer's risk today is basically negligible. Okay, but obviously it will increase over time, and so you can actually. Here's a great thing that we can do, and I probably want to fix this about the platform because I think it can be a little bit confusing when someone comes into the results for the first time. I'm going to go to Alzheimer's. Wow, you're carrier for other things. We should talk about that after. Okay. Oh wow, you're an E4 carrier. Okay, that's interesting. So you have generally people with E4 marker are at a higher risk for Alzheimer's. However, your other common genetic variants put you about an average chance. Again, when we say average, again, there's cutoffs here. So I just want to be clear that you're slightly elevated. Like you're almost at 1, you're almost at the cutoff. We still consider it average, but you actually, practically speaking, are slightly elevated. What does that mean practically for you? What that means practically for you is that. Okay, interesting. Let's go to this chart. So this is typical Alzheimer's risk. This is your risk. So you have about an 18% chance compared to about 12% chance between 75 and 84. So you're slightly elevated. This is not that crazy, honestly. I mean, obviously this is really high, but this is also age related. So the baseline risk is really high.
Do you know how these population statistics are generated? Like, are these always from a particular
based off
country?
Large studies.
It's globally.
It depends. Usually it's US centric.
Yeah.
Like it's hard to get the population data. Yeah.
Right. Like I would love if you were able to control for some lifestyle factors. How would those percentages shift? You know, we're
going to be building that actually. That's a great feature we want to build. Yeah. Which is to say like, what happens? Yeah.
Yeah, I do like 15 to 20 hours of aerobic exercise a week because I train for triathlons. So like, I'm curious to see how that would affect it.
No, 100%. And the thing is with this report, so one thing to know, this might confuse people. It's actually a good thing that I explained this. You see how this 75 to 84 is 17.7, and then here it's 17.7. So we pull this risk, which is age adjusted, right? If you click into the report though, it says basically, so you're negative, and then it says that, okay.
You're still sharing the PDF if you've gone back.
Oh, shit. Here, sorry.
Yeah.
Can you share my screen?
Yep.
Okay. So, we say, Evan, with the score of this, the common variance you need to place you on an average risk. Given you 27, though, your risk of having Alzheimer's disease is very low. So that's very important. Obviously, right now, you're not going to get Alzheimer's. But then we say, however, Alzheimer's disease is an age-related condition. People with risk scores similar to yours, but you have around a 21% chance, right? So it's higher. So be mindful as you age and may develop later in life. I would probably fix this, honestly. This is one of the things that I wanted to fix. That's a little confusing, I think, because I know the platform really well. But if someone doesn't know, they might be like, "What's my risk?" Like at age 70, not at age 35, because obviously right now it's really low, but in the future it's going to be really high.
Yeah. I'd love to know what genes I'd love to know what genes I have that are protective. So this seems to be that
Yeah,
I have an E4 gene, but I would love to know what other genes I have that are actually bringing that back to average. What genes are protective?
yeah. I'm just doing a quick look right now. You actually are pretty. This kind of checks out. Interesting. So you can see ApoE here, which is a common marker. It's pretty high effect. You see the ApoE. It's very well known. Then there's these other markers, and you can actually download the table too if you're really curious. Here, let's do that. You can actually download the complete list of SNPs. You can actually see what is bringing you down in risk, right? Because usually people with ApoE E4 are higher, but there are other variants put you at lower risk slightly. And to be clear, you're slightly elevated, but you're not above 1. So you can see your risk score is 0.786. I would say too that like this is the beauty of polygenic scores, right? Like one genetic marker doesn't tell you much, but many do.
Yeah.
And that's why we're continuing to build in this way, which is like if you had just done another genetic test, they would say, oh, you're at increased risk for Alzheimer's. They wouldn't have said how much. They would just say, oh, based on this one marker, you are. But turns out this one marker is just one of many markers that impact your risk. That's really important. I just want to communicate to you.
As more people do Nucleus, do these models improve? Do they shift and change?
Yeah. Oh, yeah, they're going to shift and change and improve. Yeah, absolutely. So you'll see we're actually pushing out some updates very soon for everything and updating all the models and making them better. Yeah. Okay, let's go back. It's 11:44. Time flies. You're having fun. Let's see. Restless leg syndrome, 0.985. Insomnia, 0.932. Interesting. Do you have any insomnia or do you have any restless leg syndrome?
I would say I only have maybe bouts of insomnia when work is too. No, I don't think so. I'm a regular, I'd say, distribution of being able to sleep.
Okay, that's good. Let's keep going.
I'm really curious about depression. Go to depression. I've never ever suffered depression in my life, but I'm curious about this one. Like what I would love to know and what I'm personally curious about is what I have that's protective here. Because
you're at a very slightly increased risk. No, this is important. Genetics influence of depression is not well understood. So just know that as you interpret your results. But you are slightly elevated. We analyzed about 500,000 markers. Let's see.
That's worth restating. There's 500,000 markers that are contributing towards the model.
But they're extremely weak. They're
extremely weak.
Emphasize. Yeah,
and they could be coding for proteins that do all sorts of stuff that have nothing to do with
interaction. Yeah, it's very, very complex. I mean, depression is not really a well elucidated phenotype. Like sometimes the genetic models, right? It's like the better characterize what the thing. Like you can't predict what something is if you don't even agree what it is. Right. A great example of this is like intelligence too, which we can get to if you want to look at your intelligence results. But the intelligence example of this is like, what is intelligence? You ask two people, they disagree on it. Depression is very similar, right? Is it clinical depression? Is it someone saying I'm sad every day, right? And that the more the phenotype's murky, the more the models are shaky. That's why height is such a good model because it's very well defined and very easily measurable. Right, something can be very well defined, but actually easily measurable, like cancer. Like cancer, the state of having like tumors, like they're well defined, but it's not necessarily easy measurable. So, anyways,
I'm really curious if you can guess my height. You've obviously never met me, so I'm curious if you can guess my height.
All right,
from my
let's see. Let's look at that right now.
BMI height, interesting.
1.72. You need to translate into feet for me. Lower, higher?
Hi, I'm taller.
You're taller? Wait.
Yeah.
Translate this into feet for me. What's your actual height and above average?
183
centimeters.
And that average IQ prediction is very wrong as well.
It's okay. The IQ has huge error bars.
You must have a bad intelligence system here, Kian. This one's not.
There's an old joke about this. We love to have it in the company. There's huge error bars here. You can see how big the error bars are. I mean, it's huge.
That's so funny. Though. And how many genes are contributing towards intelligence? All of them?
Well, this model includes about, I think, let me see, about 500,000. I want to say. Where is it? Where did it go? Oh yeah, 500,000. It's based off of this paper. About.
I wonder, are they the same 500,000 as that contribute towards depression?
Generally speaking, there's possible overlap between the polygenic predictors, but they're actually, relatively speaking, pretty disjoint. So I'm sure there's definitely some overlap between those two, and sometimes it's like apply trippy where these things are actually associated. And they might be very similarly associated, but generally it's actually pretty disjoint. So like if I change one genetic marker, and it won't necessarily change another. It's just still an active area of research, but that's how that works.
Super
Um,
interesting.
these
So
models are the intelligence model needs to improve a lot. I mean, this is still pretty weak. I mean, look how big these error bars are. It needs to get better. I mean, we say that in the first sentence. We say the understanding is limited.
how big are those error bars? It's saying that my
Huge.
those error bars need to be bigger, man.
I mean,
You're-
look at
you're-
this. I mean, you're off the charts. You're probably like up here, right?
You're
You know?
capping me out at 137 here maximum
Listen,
on the error bars. I'm not liking this.
we gotta improve the model. What was your last IQ score?
I've never done an IQ test in my life.
I'm just messing with you, Evan.
You have that result though. That's funny. I've never taken
Yeah,
an
you can-
SAT, obviously, because I'm not American.
What was your test score? Really high?
Well, I can give you a percentile in my
Yeah, what's
final
your
year of
percentile?
college. 98th.
98. Do you mind if I put an SAT score for you? Train the model better?
Sure. How predictive do you think the hypothetically perfect genetic intelligence model would be?
Oh my God, what a favorite question that I happen to have the answer to right here because I geeked out and put it in the report, even though no one actually reads this section. So if the genetics of IQ are completely understood, you'd expect the error bars to be much tighter. So this is basically today. If it's completely understood, you expect it to be much tighter, but still you see there's error bars. I mean, that's the thing, you know, if you talk to Plumman about this, wherever else, you expect IQ to explain about 50% of genetic, or excuse me, you expect about 50% of the variation in genetics to be explained by IQ.
Yeah.
Yeah, so 50% of the variation in IQ to explained by genetics, excuse me. And so you can see here that the error bars are much tighter, but again, there's still stochasticity, which makes sense. I mean, there's always nurture, right? There's always going to be error. And I think a lot of people
Yes.
misunderstand that. They think that like they can build some perfectly predictive genetic model for IQ. You can't. So that's important to say.
Yeah, I'm also kind of skeptical of your model assuming perfect level of genetics because I'm also a little bit skeptical of that because you don't know what is you don't know what's unknown.
Well, you do know actually, because basically what you do is like thanks to Plumman, who's on our advisory board. Plumman has done a lot of studies to see the theoretical maximum effect of genetics on intelligence, and you do that by looking at twin studies. So you take like identical twins and compare them to like basically non-identical siblings, and then you
Yeah.
basically see how much more similar the identical twins are, and then scientists can get estimate based off this, because obviously if you think about it, identical twins are sort of like a nature experiment. It's like a natural experiment. How much more similar the twins are. And so then you can use that to get estimates of like, about 50% of IQ can be attributed to genetics. So like basically you can predict like an upper bound of genetic contribution. And these things get quite complicated. But basically you assume that upper bound here. And then by using that upper bound, you can then get these error bars. But yeah, I mean, honestly, the best person to ask about the genetics of IQ is Robert Plummer.
Yeah, I'm speaking to him in 2 weeks, so I'm excited to do that. That makes sense. Twin studies are very good methodological science experiment. Like they give good results, reproducible
Very
results.
reproducible.
Interesting. Very interesting.
Let's see.
BMI,
So wait, what's this in? You can see the things for height is much more tight. What is 172 centimeters in feet? I need a translation here for this poor American. That is a very good model.
What's that, like 5'9"?
5'9"?
Something like that. I'm 183 centimeters, so this is off by 10 centimeters.
You're 183 centimeters. Can you translate this to inches? I need to get an intuition. So there's some error bars here.
6 foot on the dot.
What is 6 foot on the dot?
883 centimeters.
Okay, so you're 6 feet.
Yeah.
And then 172 centimeters is how tall? Like
probably 5'9", 3.3 centimeters, right?
Okay, so it's like 3 inches off. Interesting. That's not terrible, but yeah, that's within the expected error. I think you must have, drank a lot of milk growing up. How tall are your siblings?
My sister's pretty short, but my dad's a bit taller than me. My sister's like 5'5".
5'5". How tall is your mom?
Like 5'4", 5'3", short. My dad's like 6'1".
That kind of checks out then. Interesting. We can make this prediction for your children too and give a confidence interval because obviously there's always going to be this kind of nurture component. I know IQ
Below
we're
average
saddened
muscle
about.
strength. Sorry, you're placing I have huge doubts on this entire platform now. I have
I would say, Evan,
absolutely.
there's a reason why this is the traits category and not the homepage because this is for more fun, honestly, the trait stuff. So take this with I would take this stuff with more like kind of fun.
It is
For me.
it is
Does
interesting
your
though,
pee
and
smell like asparagus? Yeah.
it's an important point as well. Like risk taking. Like I've been an entrepreneur straight out of college, so like I would say very high.
I'm very high too, but Nucleus put me in
propensity
below.
for risk taking. Male pattern baldness. My
very
hair
weak.
is as thick as they come.
It's very limited. These models for traits is more for fun. That's important to say. I mean, that's why in the reports we say it, right? We say, hey, it's limited. For intelligence, we do the same thing. We say, hey, actually for intelligence, we even had this that says science, current, and it's limited. And for us, it's very important that we just communicate this to customers. We're not here to obfuscate. We're not here to overclaim where the science is. We say, hey, here's what the science says, and then it's very important that customers feel empowered, right? Because I think what happens if you don't do this, customers don't know, and they think there's some secret model that can perfectly explain IQ that just doesn't exist. And so that's why I think I really tried to communicate to people, hey, the way genetic models work is there are better models and worse models. So think about if you take it to the extreme, like cystic fibrosis or Huntington's, like a rare, not Huntington's, like hemochromatosis, that's another kind of genetic model where it's just one gene. That's it's a lot more deterministic. Then there's these polygenic stuff, which is more probabilistic. And then within the polygenic stuff, some are more predictive, some are less predictive. And that's not something that we want to hide away from as a company. Just yep, these things are better, these things are worse. Clearly communicate that to the patient. Generally speaking, a lot of the disease models are better. Yeah,
it's definitely an important point to make. Cool.
Can we go to family?
Yeah, let's do family
results. Yeah, I want to go to family because this is going to be really interesting. We don't have too much time. Wow. So your family results, these are the implications. So carrier means that you have a genetic risk for a condition. Excuse me. Carrier means that you have a genetic marker for a condition, but doesn't necessarily impact your risk, but could impact your future child's risk. And if you're not a carrier, it means that you don't have one of these genetic markers. You have 3 different carrier genes.
So this is genes that I'm recessive for.
Correct. Correct. And by the way, this is really cool because think about it. Think about all the results we looked at, right? It used to be the case that these were literally 1,000 different genetic tests, 2,000 different genetic tests, but now it's all combined into one.
I've never even heard of this Johansson Blizzard syndrome.
Yeah. Usually people have never heard of the condition.
The hell is that?
It's quite common. Take a deep breath. Taking big steps toward having a healthy family. We're gonna add your partner, but you don't have a partner. Right? Do you have a partner?
I do have a girlfriend. She hasn't done. She hasn't done the test. We need to do that for round 2.
Looks like we have to gift it to her, Evan. We're gonna do that. All right.
100%.
Let's go. Let's look at your results. Okay, interesting. So I don't know. We talked about hemochromatosis. Let's go to UBR1 Johansson Blizzard syndrome.
Have you heard of this syndrome? Do you know what this is?
No, let's see what it is. It's a rare genetic disorder affecting multiple body systems, are present at birth. Okay, wow, this is a really severe condition. So you want to make sure your partner does not have it. Obviously, you want to do carrier risk. You can look at that. Interesting. There's a 50% chance to have thing, about 25% chance it's not affected. This is if your partner is a carrier. Partner is not a carrier. 2/4 will be carriers. 2/4 will not be affected.
And this is a really debilitating illness.
Yeah, this would be really bad. Yeah, this would be really bad. This is the genetic marker if you're curious to actually look in your VCF file. So you're heterozygous for this genomic location. This is cool. I know obviously I built it, but I still love looking over it and seeing patient results because I don't, I look at all my results all the time, but not other people's. So it's really cool. Yeah. So do you have any questions about this?
No, I just didn't know it existed. So yeah, this would highlight a very important why Nucleus family, right? So my girlfriend would do this test. If she is also a carrier of this gene, we would probably think quite strongly about doing IVF, right? Because this is a pretty serious.
Exactly.
This is a pretty serious illness, but it's rare. Does it say how many people carry this recessive gene?
I can get the data for you if you're that curious. I don't know if it says the math here, minor allele frequency.
Just curious. I've never even heard of it before.
It's probably I mean, being a carrier for it's obviously going to be more common, but generally speaking, this is not something that's like cystic fibrosis. This is substantially rare. So
How many carrier genes do people in general have? Is 3 an average amount of carrier
3
genes?
is above average.
Okay,
People usually have 1 or 2.
interesting.
I mean, having hemochromatosis, again, this is the most important result of your nucleus thing. Let's see. Also, you can see here that we look for over 900 conditions, and we're actually about to add 1,000 more genes. So the platform is constantly updating, which is pretty cool. It's like a software problem. Let's see.
Very cool.
Thyroid dyshormonogenesis 6 is a rare genetic disorder affecting thyroid. I'm sorry, I'm not laughing at the results. Obviously, the results are very serious, but or not very serious because you're not impacted your future kid reaction. I just think it's like the naming I always find to be so like ridiculous. Just hormonogenesis 6. Like
No,
how about 5 and 4?
you're not going to
Um,
offend me, man. Don't worry.
yeah, so it's
Thyroid
very severe.
dysfunction.
Um,
Interesting.
Same thing. 114. If your partner is a carrier, if your partner is not a carrier, you're fine. If you want to see carrier risk, you can see carrier risk. This is usually confusing for people, and sometimes this can break in certain ways because of the way genetics is complicated. But let
I
me
think it's a good way of
see.
displaying the information again as a communicator. I think if you have 4 kids, you can just do the maths very easily.
Yeah,
And I
that's
want
the
4
initial
kids, so
position.
this actually is all applicable to me.
Yeah, that's Nucleus.
Very cool, man. Should we finish it there and then go to a few more questions? Because I would love to dig
Yeah,
into more
let's do
stuff.
that.
You want to stop sharing?
Yeah.
Thank you so much for the run through, man. I really enjoyed that. I think that was really, really cool. I think the platform looks genuinely amazing. It's really, really cool. I love the way you've laid out the information. Super easy to understand. I am really cool. I hope that we can do it with my girlfriend as well, and we can maybe hop on
I think
another
we have to do it
podcast.
with your
That would be
girlfriend. I
another.
think that'd be actually great. That's great content.
Yeah, for sure. All right, let's ask a few more questions because I'm really curious on a few things.
Great, yeah. Hit me with them.
What is Nucleus Embryo?
Oh, I should say the demo for Nucleus Embryo. Nucleus Embryo is a genetic optimization software. So basically, you can use it to reduce your future child's risk of getting like some sort of chronic disease or even some like rare disease. Like we looked at some rare conditions today, like hemochromatosis. We looked at Uber syndrome, whatever it's called. Like these conditions as well. Using our technology stack from adult screening nucleus embryos, you can make sure we're rid of any hereditary diseases and
So,
common diseases like cancer.
what was the general response like when you made that announcement? Because I was
You
following
tell
it
me,
quite
Evan.
closely. Yeah, it was very interesting, and I've been telling people in my life, and even lots of very interesting scientists and geneticists who I've had on the podcast, what their opinions are. But I'm kind of curious from your perspective, what did you think of the response to that as a product launch?
I think response was fantastic, honestly. Like all in all, I think there's certain constituents that for various reasons might gripe at nucleus embryo, but for us it's really about the patient. What does the couple want? What does you and your girlfriend want? Right? What is the patient coming to nucleus? What do they want? And no matter your background, no matter your socioeconomic background, no matter where you're from, no matter your religious beliefs, everybody wants a healthy child. And I think Nucleus helps that. And so I'm just very proud of the software. I mean, the thing to remember with genetic models is they're going to get better and better and better and better. Okay, we saw this today in the application. Right? Certain models are weaker, certain things are off. Right, your risk taking's off, my risk taking's off. It's not a good model. And so we provide it because patients want it, but something like risk taking, it's very weak. I don't even think we have that in the embryo product because it's just so weak. And so I think remember something like height is very strong, something like breast cancer, like diabetes, is very strong. And then obviously the rare genetic stuff is, critically important, right? God forbid you pass down a rare genetic condition to your child. And now you can use all this information from rare genetics to cancers to diabetes to schizophrenia to Alzheimer's. Alzheimer's is a great example to reduce your baby's risk. And I think that's fantastic. That's phenomenal.
Yeah, I couldn't agree more. I think there's very obvious aspects of the product that are amazingly beneficial and no one can really argue with. But for
Exactly. Yeah.
some reason, some people seem to have a very gut aversion to the intelligence. I asked a lot of different people in my life and a few different scientists on the podcast, like Philip Ball, editor at Nature for 20 years, written over 35 books, polymath, just written a book about genetics, which I think you should read and you should talk to him. Super interesting. Was quite against a lot of things related to ranking by intelligence. Why do you think people have an issue with intelligence specifically?
Well, Evan, I think we have to. There's implicit in this question. There's two questions. Okay, one question is where is science and where is politics?
Yeah.
It's an important question, right? People can have opinions. There's the concept in economics, which is like, what is true? Like, if X changes, Y changes, and then, what should be done based off that. And those are separate questions, right? We have to first establish what is true, what is scientifically known. And then the second question is whether that should be done, or the implications, the societal implications. They're different questions. Often when I find in this conversation, these things get really, really mixed up, where people pretend like their political views, candidly, are scientific, rigorous views, when we need to put a line in the sand and say, this is science, this is what the science says. The implications of that science can be debated of what to do about it. But that's one important point. So when the scientists, for example, what I see is that people often will interpret genetic information based off of their prior views on really whether they think the world is more genetically driven or not. So for example, I could say to you that intelligence is about 50% genetic. Another scientist might say, I actually think it's more like 40%, right? Both numbers are legitimate. They're both scientific. They're both data that might suggest that, right? But depending on what you want to believe to be true, you can pick any number. Now, there's no doubt that, intelligence is driven by genetics. I mean, one thing I always like to say that I think always gets lost in the conversations here that I find interesting is like, as a customer, as a patient, as a user, you always have to trust your own eyes and ears, okay? Tall parents produce tall children. Obviously, there's the genetic component there, right? You can be in class with someone who grew up next door to you, and they could be exceptionally better than you in math. Obviously, there's something genetic there, right? It's not like they went to math training from ages 0 to 3 and you didn't or something, right? People just have different propensities. Ask any preschool teacher, ask any parent that, right? That's what they'll say. People have different propensities, right? In other words, I'm saying is that it's very obvious that genetics plays a role in height. Everyone agrees there. It's very obvious that genetics plays a role in intelligence. Everyone agrees there. And so I think we always have to be delineated between what is like actually like science, which is like, we know genetics shapes intelligence. We know there are genetic models today that can shape intelligence. And then what's politics, which is, should people rank embryos based off intelligence? And on that point, to answer that question, should it be done, which is again, it's a separate question that what is true, I would say it's up to the patient. I mean, who am I to say? Who's a scientist to say that a patient shouldn't use large population biobank studies, right? You saw some of the papers we cited in the thing. These are large studies in hundreds of thousands of people, right? The intelligence paper, for example, 100,000 people. Who's to say that as a consumer, as long as they understand limitations, which are very careful to communicate, who's to say that they should pick or not pick based off what? I mean, I believe in individual liberty. I think the couple's right? I don't think it's for my right to say, I'm not going to tell you about hereditary cancer risk because morally, I don't think that's right. I mean, that's crazy to me. I'm never going to do that. So I really want to empower the patient. That's one. Two is, I think that people, I think sometimes think that these things, like people always mention like Gattaca, for example, like DNA is not destiny. DNA will never be destiny. People have this myth in their head that if you look at DNA, you can then say, oh, you're going to be this smart. It doesn't exist. I told you the error bars, even in the best possible case, there's still going to be error bars, which of course that's true, right? Like if you take a kid and you look at post-industrial revolution, Persians, my people, we gained 8 inches in height. Is that because our genetics, mutated? Of course not, right? The Flynn effect, Flynn effect was basically what the story is. You give iodide to the population, IQ, I think, jumped by like 8 points. My point is, obviously, there's going to be environmental factor here. Obviously, there's going to be stochasticity. And I think once people understand that component, they start seeing it for what it is, which is it's a tool. It's not deterministic. It's not end all be all. And because the real question you're asking, Evan, here, the real question, sometimes I think the important thing when someone asks me questions about intelligent genetics, there's always an underlying question. The underlying question is, should I be scared of this? And really the underlying question to that is, do I have free will? It's my own personal opinion. But if people are really asking, is my DNA deterministic or do I have free will? And that I think is actually an even more interesting question to ponder about. So really the question of intelligent genetics is not actually about genetics nor intelligence. It's about, do I have free will?
Yeah. And I totally understand your argument about the transparency. I actually didn't know that's how IVF was even done, that the doctor will generally make that decision. And I think that's
the doctor will pick an embryo, yeah.
I think that's
the doctor
the
will randomly pick an embryo.
They randomly pick an embryo.
Of the viable embryos, they will randomly pick one. Which, to me, I mean, if you're picking your baby, I mean, you're probably like, just give me all the information and get, because at this point, you have to make a decision anyways, right?
Yeah.
So if you can pick, if there's 5 babies and you have to implant one of them, obviously you want to pick the one with slightly lower risk for Alzheimer's. I mean, right? Like, obviously it's your child.
Do you think you'll have any issues with people coming to you 20 years later and saying that you said my child was going to be intelligent?
Well, to be
Genuine
clear,
question.
we never say the child's going to be intelligent. We say it's propensities, it's dispositions, right? So like, even if you pick a baby with low Alzheimer's risk, they can still get Alzheimer's, right? Similarly, you can say baby's going to be 5'9", but then they might be 6 feet, right? So I think, what's most important to me is that people understand this. They understand that these models are still stochastic, they are probabilistic, and that's communicated. I think the thing is, the most important thing when someone does embryonic selection is they shouldn't look at a model and be like, oh, my IQ is going to be, whatever, 101 or above average, whatever it is. No, you should use it as like a relative measure. Like, okay, this embryo is slightly smarter. This embryo is going to be slightly shorter. This embryo has a greater risk for breast cancer. Usually what we find is that people will have a couple things they care about. Usually it's diseases. I care about let's say, for example, my grandfather died of Parkinson's. I don't want my baby to get Parkinson's, or I want to do at least anything I can in my capacity to reduce the risk of that happening. What do?
Yes.
I go to Nucleus Embryo. I see the embryos. I have whatever, 5, 10, 15, 20 embryos. I sort them by that, and I pick the one with the lowest Parkinson's risk, right? And so that's the thing to remember, as also like people usually don't build some complicated min-max function here, right? They don't like look at each feature and then like be like, oh, like let me maximize it. No, it's like a couple things they care about, and then they pick across that.
Yeah. I think most of the issue is in the not understanding the results and misinterpreting what you're actually saying. 100%. And I think you have been very clear, and clearly throughout the product, there is a very clear intention on communicating the core pieces of information so that even if someone has never taken a science class in their life, they're still able to interpret their results and make those decisions themselves. So I completely appreciate from the transparency perspective. Where it gets very controversial is editing. And I think you have to accept that there's aspects of genetic editing that are very controversial, and we're heading into very murky waters with genetic editing. First off, can you give the state of the art? What's kind of possible at the moment in relation to genetic editing, and then what isn't? And then I kind of want to get your general opinions on the future of genetic editing.
Well, Evan, you might know that in high school I did a lot of gene editing work, and that was actually in the Wall Street Journal, from the same journalist who recently wrote our Wall Street Journal article on embryonic selection. So 8 years in the making, if you will. I'm not sure if you know that, but that's a fun fact about me and my interests. But generally speaking, when you think about gene editing, so the first thing to note is that people often will say, okay, we're going to engineer for intelligence, we're going to engineer for these things. Okay, let's actually break down what this means. So first things first is that many of these conditions, like breast cancer, like height, like intelligence, they're called polygenic. So we saw this today, actually, in our presentation. They're driven by 500,000 markers. Okay, the thing is that you don't necessarily know which marker is causal.
Yeah.
So I can know that the marker is associated, and association is good enough for prediction, but it's not good enough necessarily for mechanism, right? I can use it to try to find the causal marker, but in other words, let's assume I have the perfect gene editing tool, which is already quite the assumption. I don't have the perfect gene editing tool. And again, remember, we're not making one edit here. We'd be making 500,000 edits.
Yes.
That's a different kind of engineering task required. But let's put that to the side. Let's assume gene editing was a solved problem. I solved gene editing. What would you edit? People would say, oh, there's 500,000 markers intelligence. Edit all the markers. But we don't know which one's the causal. So that's another problem. Like, you have to identify which are the causal markers. And once you identify which are the causal markers, then you can begin to engineer, do multiplex engineering. And so there's a long way to go, even so, in the understanding of these. Because think about it, even intelligence, I told you the model is very modest today. You still need to build a much, 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 much better intelligence model to actually be able to, you need to build a better intelligence model to actually be able to engineer. In other words, you have to first understand to engineer. People always get this wrong. They always think it's like an engineering problem, when it's as much an understanding problem as an engineering problem. If you don't know what to change, it doesn't matter if you have the capacity to change it. See what I'm saying? So that's how I think about it.
I completely get that. But let's take a different trait then, for example, a trait that might be possible to edit a little bit sooner. Let's take a trait like height. If it were possible to take an embryo and perform the genetic editing and increase the probabilistic height of that embryo by 2 inches, do you think, would that be a service that Nucleus Genomics would offer if it were possible?
I think that that's just not practical today, and won't be for a long while. I would say that I think the thing to remember about this is there's no point in gene editing something that you could solve with embryonic selection. for example, let's say you're a carrier for, you are actually a carrier for some severe hereditary disease. And let's say that your partner is as well. Okay. Someone might say, okay, well, let's look at the embryos and find the embryo that has both bad copies and let's engineer it so that it doesn't have this rare disease. That's a very kind of good use case. But if you just make another embryo, that next embryo might not have that anyways. It might not have the combination of markers. See what I'm saying? So like when you talk about height and engineering, it's like 2 inches of height. It's like, sure, you do that today with embryonic selection. You can make 10 embryos or 5 embryos, and you can pick the one that's 2 inches taller than the bottom one. And so there's no point in doing gene editing for things that could already be solved with the genetic stack. That's kind of the way I think about it.
I understand that now the technology is limited, but as someone who is leading possibly one of the most important genetics companies for the next decade, and you do sort of shoulder a lot of responsibility of the technology that's being built, I am very curious about what your opinions are specifically on gene editing, if that technology is possible. Like, we've no idea how AI is going to impact genetics information, right? That exponential curve could keep increasing, and genetic, as you say, the cost of doing the tests will go to zero. The models will just keep on improving year after year exponentially. In 10 years' time, we have no idea how good they're going to be. Would you agree with that?
How good the genetic models will be.
Yeah, like they could be. They're likely to be so much better that it's hard to even imagine. And
yeah,
editing
we could
technology,
estimate it, but yes, they're going to be orders of magnitude better as a fair characterization.
right? So you are going to have to make decisions about what kind of gene editing services you offer, right? Because it's going to be possible. There's going to be options. It's going to be uncomfortable for people what's possible. It's uncomfortable for people what's possible now. I'm genuinely curious, and I'm not trying to be in any way combative. I'm really curious about how you think about this as the technology improves.
Well, I do believe in the genetic stack. I do believe in going from sequencing, analyzing to engineering DNA. I do believe it should be made like so. Let's take a step back even further here and saying like gene editing. If you really think about it, you're implicitly talking about a entirely new reproductive stack. So we're going to be going from right now just naturally conceived. Great. Then there's IVF plus kind of organic womb. Then it's going to be IVF plus artificial womb. Right. So like IVF plus artificial womb plus maybe gene editing, probably. And then baby's born. Does that make sense? Right. So like eventually, like I think the more interesting like meta point is that in an interesting way, reproductive technology is going to be the great equalizer, because a woman can choose if they're going to get pregnant or not. And that technology is going to be made ubiquitous. It's going to be available globally. It's going to be like a vaccine almost. And anyone anywhere will have access to, I think, this kind of genetic stack that forms. So I definitely think it's going to be a future where everyone has access. It's cheap. It's accessible. It's well elucidated. And yeah, that's kind of the way that I see it. But I do want to emphasize again, we are far, 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 far from that future. I think it's definitely an interest. I would say that by the polygenic tendencies of things, you'll never be able to get deterministic results. So often I think people think, okay, I can edit this and then get the result. And similarly, again, these things are polygenic in nature. They're very complicated. You don't just make a simple edit. And then there's the engineering problem of like actually CRISPR it. So it's multifold. But do I subscribe to that future? Absolutely. I mean, I've absolutely said future, and I think the technology has to be made completely ubiquitous.
We can actually take an example that exists now that is deterministic. At least to the best of my knowledge, I'm pretty sure, where in the US you can choose sex with IVF, but you can't in Europe. Europe has made that illegal. Yeah, so in Europe, if you're doing IVF, you can't. I believe this is correct. You can't choose sex, but in the US, you can. So that's interesting that there's already a regulatory difference in the choices you can make related to IVF.
Yeah, there's many more than that, by the way. Like many more.
Do you have? I'm curious. What other decisions?
Yeah, I mean, some polygenic screenings you can't even do internationally. Like Germany is very restricted. Like Germany is very restricted. The UK might be restricted. There's a couple like Spain. Maybe Spain is a little more liberal, but it depends on which your country. But there are countries that are very much against polygenic selection.
Very interesting.
But I think if you think about it too, Evan, like the most important decision you make when you make your child is who's your partner. And when you choose your partner, let me tell you, everyone knows this. I want a 6'5" finance man, right? Like people say this all the time. They want someone that's tall, that's smart, that's handsome. People are selecting these things already, and so that's the thing I think gets lost too. It's like embryonic selection. You're not doing anything new. You already pick your partner. Embryonic selection is limited ultimately by who your partner is, and so it's sort of a weird. It was always a weird argument to when someone's like, "I'm completely against embryonic selection." So then, should people marry randomly? Of course not. Right? Ultimately, it's the combination of the DNA from mom and dad. So that's another thing I think to factor in as you kind of as whoever listens to this kind of evaluates this.
I think that's completely fine as it comes to embryonic selection. I'm kind of more curious now about embryonic editing. Like there is just things that are going to be possible in 5 years, and I'm really curious on where. Do you have any slippery slopes? Like, do you think there's any areas that you think Nucleus Genomics with a partnering lab or without a partnering lab will be able to do, but you won't want to do morally because you just think that that's not a good thing to do for humanity, even though there might be a huge financial incentive to do it. Your investors might be pushing you to do it. Maybe there's a huge demand from a certain set of people to do it, but just morally inside you think that you shouldn't.
One thing to remember is that, the best way to predict the future is looking at the past. So to understand like Nucleus as a company, right? Think about our guiding principles: transparency, customer obsession, ubiquity, openness, right? In other words, like any new technology that we adopt would follow the same principles. I think that, as a company, we fundamentally believe in patients. Okay. The patients have the right to choose, the patients have the right to access technology. And part of it, it's actually very similar to AGI as well, or artificial intelligence, in that like people need to be stakeholders in the tech, right? Like, you know how there's like GPT-3, GPT-4, the evolution of like all the different models. The same thing's happening in genetics, right? Like the models are going to get better and better and better. This is like maybe 2.5 or something, right? We get to 3 and then 3.5 and 4, and then people are like, oh, this doesn't really work. They're like, oh, this really works. And then, people need to, I think one thing to know is people need to see this more as a software problem. I think people sometimes, clinicians are too conservative in this way. Like for me, if there's a mistake, I fix it, right? It's software. We fix it. We make better and better and better. Not saying a mistake. That's not even great saying it. It's like saying like 2.5 and 3 is like a mistake. It's like you get a better model, you get better data. You train larger and larger things, and then the models get better, right? It's the same thing. And so yeah, I think that we're going to follow all those guiding principles as we think about the frontier technology. I do want to say though, and it's very, very important. It's just patients want to have healthy children. Period. Where the IVF industry today is, and where Silicon Valley is in their mind, I don't think there's a greater chasm in the world. Genuinely. I talk to patients every day. People on their mind is not, multiplex gene editing. People on their mind is, I don't want to give my kid, PKU. I don't want my kid to have debilitating disease. I don't want to give my kid breast cancer. And so I think we have to remember that, like, technology itself is one component. Ultimately, you need to be mindful of the go-to-market strategy. You need to be mindful of how do you actually bring the technology to people. That's actually often a much harder thing, right? In a lab, someone can build, someone actually had. I mean, you saw there was already gene editing. I mean, this is actually a great example. The recent CRISPR baby that was gene edited, right? They did gene editing to cure this baby's life. That's wonderful, amazing scientific innovation. I'm all pro that. Obviously, I'm pro that. Everyone in the world celebrated. Scientists, medical community. Here's the thing, though. If mom and dad had done Nucleus, that baby, which was in pain, which caused a lot of medical system pain, which the parents were suffering, right? That baby could have not had that disease in the first place, right? So this is really important. I want to really say this, which is like the ultimate preventative measure stack. Again, there's no point in engineering for engineering's sake. It really makes sense to use the entire stack. If you start, like, the entire stack is far from being used. Millions of babies are still born with severe hereditary disease, right? So even if you could develop the end game of engineering, right? Like genetics in IVF is like from 20 years ago. I mean, people are still buying SNP chips in 23andMe. And I think that's why I always get kind of caught up in here. It's like there's a tactical, practical thing here that I think sometimes people miss when they opine about gene editing. And I want to remind all listeners that, you can develop technology, but technology in a vacuum is technology in a vacuum. No one uses it, no one understands it, etc. Right? It is the LLM before it was launched, before it's ChatGPT, right? Which there's actually not much utility to that. I mean, so I think that's one thing Nuke is trying to do, trying to increase the technology we have today, the advanced technology we have today, to everyone. That's our mission, and that's why we're so kind of loud and proud about it.
I'm very pro Nucleus. I really am, and I'm very pro the technology, and I'm really pro the company and everything, and I genuinely am. But I think everything you said there is rational and makes a lot of sense. But I think it's very valid to have concerns about the future, right? I think it's very valid
Absolutely.
to have. And
I mean,
and
absolutely.
I think
there's no doubt about that.
And
there has to be responsible stewards of this technology. There has to be.
right. Is there any part of it that you're scared of? Like you're embedded in this system. You know the capabilities maybe better than anyone. Like 5 years down the line, like what potential thing could pop up, even if it's not Nucleus Genomics, say it's the next competitor of Nucleus, whatever it is. There's definitely technology that's going to be possible quite soon that people are not going to like, and it's going to be used because there's a demand for it. Do you have anything in your mind that you're like, that's just, I'm scared of that. I don't want to bring the company that direction?
Well, to be clear, obviously I'm very scared. I mean, there are many implications of genetic testing technology. Okay. Ultimately, technology isn't evil or good inherently. It's who uses the technology, how do they design for the technology, and how do they let people access that technology. Usually when people paint the very negative case in genetics, what they have is they'll say something like, and you actually see this in pop culture, people will be like, they'll make a lot of assumptions. They're like, oh, it's deterministic, and there's some evil, corrupt, totalitarian government that exploits this technology. That's always the narrative. There's this evil government, which makes sense given the history. And I think I want to remind people that evil totalitarian governments, okay, is ultimately independent of the technology. Like a evil government without even any genetic testing technology did horrible things, right? Horrible things. And so ultimately you have to have good actors using tech. Tech isn't inherently good or bad. It's just like AI, right? It's like who's using the AI systems, right? Is it America or is it China, and for what purposes, right? And so I think the thing that I always lead the company by is this idea of being kind of responsibility, high extreme responsibility, and care and transparency. I think one of my beliefs is that sunlight is the best disinfectant, and that anything we do it openly. I think a lot of startups in this space, for whatever reason, it's kind of weird. They're very quiet, very secretive. And, my secret model explains 1,000,000%, and I don't buy that one bit. And so, what I can say is that we want to be transparent. When we open it, we need to be really responsible stewards of the tech from preconception to engineering. And then one more thing on that is that I, as a founder of this business, I really want to emphasize what is true and will always be true. We will not do gene editing for purposes where you can use the rest of the genetic stack to solve. And for the very foreseeable future, that is the case. Where you can use the rest of the stack. It does not make sense to gene edit. And I give the example of the baby, in that if they had done nucleus preconception screening, there'd be no reason to actually even engineer the baby in the first place, which costs a lot of money and cause a lot of suffering, right? So again, we can use technology today to do preventive medicine at the beginning of life. That itself is a huge leap forward for humanity.
I agree. Can you talk about anything that you're building internally at the moment that you haven't launched? Is what's being cooked up in the labs at Nucleus at the moment? What's on the roadmap?
Well, we're improving our analyses. We're always improving our analyses. We're building better and better and better models. We're adding more genes. We have some very exciting announcements coming out in a couple of weeks that you should keep an eye on for. We have some fun features coming out that I think people are going to really like, and so I'm excited.
I'm excited as well, man. I'd like to see more communication, if I'm honest. As a science communicator, I always wonder why someone like you doesn't hire a full-time science communicator who is just making genetics videos. Yeah?
Oh, yeah, we do. We have many. I mean, we do a lot of comms. We do a lot. You mean like more sci comms?
Yeah, just like going to the full extent of making like genetics animations, documentaries, like really exploring different forms of content. I know they're expensive. Yeah.
Well, no, we used to do it. People don't resonate as much as you think about it. Like, I would love to make more tech explainer videos, but we do it and people don't care. It's a really interesting problem, actually.
See, I'm more interested on the genetics rather than the tech.
I mean, yeah, when I say tech, I mean genetics. I like, you can make explainer videos, but like, you need to meet people where they are is the problem. One problem, and we can talk about this is another issue, but like one thing about when you run a complicated scientific company that's consumer focused, you really experientially realize you have to meet the consumer where they are.
Right.
Like people don't know. People don't know about whole genome sequencing. People don't know about hereditary markers. People don't know about polygenic testing. People don't know these things, right? These people did 23andMe. I mean, they did genealogy tests, right? Ancestry, right? Like they have no idea. And so I'm not saying that, I mean, if feedback's accepted, if you think we should do more comms, I think we do a lot of comms, but if you think we should do more sci-comms, let me know. I'm happy to do it. I do think it's tricky though, because you have to meet the patient where they are, which is what their understanding is, and you have to work backwards from there versus working backwards from where I want to work backwards from, because I want to start with whole genome and then say this is how it works, and this is how you do it, and this is how polygenic scores work. But then you lose people. You have to start from where their model of the world is, right? Which might be like, oh, I heard about Angelina Jolie and that she had breast cancer, or oh, I'm starting a family and I'm really want to make sure I do the right things for my kids. That's the level of understanding. There's no understanding of genes. There's no understanding of hereditary markers. They don't even know what necessarily a marker is. Maybe they know what a marker is from The Simpsons when someone falls into radioactive waste and then gets a mutation. Like, I'm serious. Like, that's the level of understanding it. And that's not a bad thing. It's not at all. It's our job to meet the consumer where it is. Anyways, that's kind of my perspective.
Yeah, no, like I completely get it. Like my day job is explaining the brain to people, right? So I think a lot about how to explain very scientific, very complicated, complex, chaotic, unknown, nuanced topics. But I would just like, my view is I want every company to do more communication. That's my view as a yeah. Kian, this has been enormous amount of fun. I know your time is valuable. That was very vulnerable for me to go through all of those genetic results live to see it all. I think it went really well. I think it was cool. I think it was super interesting. I will leave links below for anyone who wants to do Nucleus Genomics. I really do. Even though I had some questions that I am kind of cautious about for the future there at the end, like I do a huge fan of the company. I'm a huge fan of the technology. Obviously, it can do an amazing amount of good. I think you're trailblazing in cautious, murky, scary waters. And I think you'll hold that responsibility for what it is. But this has been an enormous amount of fun. I'd love to have you back again because I have more questions. But thanks so much, Kian. I really, really appreciate it.
Thank you so much, Evan. Thanks for having me.
I hope you enjoyed that podcast episode with Kian Sadeghi, a bit of a different style of podcast. Definitely felt pretty strange to have my genetics results just revealed online to everybody, like my naked photos are being spread behind my back, except it was right in front of my back. Strange feeling. Anyway, if you want to get your genetics test results done, then remember 10% off in the description. Nucleus Genomics are really great at what they do. I couldn't recommend them more. Let me know how you get on.